All right, we're talking about negative exponents today, which can be a little bit intimidating just because they look kind of weird. For example, if you look down at number 6, definitely looks a little bit crazy. We got these, number 5, negative exponents. The good news is negative exponents are really not that much of a layer of difficulty, okay? We're going to learn today how to kind of fix negative exponents, and we're going to fix them basically by using zero math, okay? Here's what you want to learn today. I'm just going to make a little box here. Math Mansion, honestly, not really my thing. I'm not that into the Math Mansion. Here's what we're going to do. Writing this down. Negative exponents. Let's change it up. Let's say just, God, that handwriting's so bad. Just wish they were on the other side. So let's just think about this. All right, I had a little bit of a brain fart, and I wanted to reword it from last class because there was a couple students that asked a question about it. So I think this will fix it up. Negative exponents just wish they were on the other side. Okay? That's it. Negative exponents, they're just like a little pouty. Okay? They're just not very happy where they are. They just got one big complaint. They don't like being where they are. Okay? So, if we look at number 2, for example, okay, I see this negative exponent. And when I see this negative exponent, I like to think of him almost like he's unhappy, right? He's just a sad little X, and he doesn't really like it. And he just wishes he was on the other side of the fraction. So this little negative 5, all he wants is he just wants to move up top. That's it. And so, if you ever see a negative exponent, you can fix it. Just move them to the other side. If they're unhappy on the bottom, move them up top. If they're unhappy up top, move them down to the bottom. So for this question, my x negative 5, which is unhappy, just move them up to the top. Now, please pay attention here. When this x5 gets to the top, it is not going to be negative anymore because he's sad in the bottom, but he's happy in the top now. So he's not going to be negative anymore. Basically, the only mistake that you can make today is if you move something from the bottom to the top and then you write it down where he's still a negative. You don't want to do that. Now that we've moved this x up to the top, he's happy, and we're pretty good, okay? In order to finish a question today, your answers need to have 2 things, okay? First of all, they need to have no negative exponents. Running out of room, so all you get is EXP. No negative exponents. Okay? If you have no negative exponents, you're good. The second thing that you have to have is one of each letter. And that doesn't make a ton of sense for number 2 because we only have one letter. But the majority of our questions today are going to look more like question number 3, question number 5, question number 6. So for number 2, do we have no negative exponents? Check, because he's a happy positive exponent. Do we have one of each letter? I mean, I guess all we have is one x. So this is the answer. That's the whole thing. All you got to do is make a positive exponent. And in order to do that, it doesn't take any math. You literally just move them up to the top. That's it. So now if we go back to number 1 a little bit, question number 1, Negative exponents just wish they were on the other side. Our answer needs to have no negative exponents. So if I see number 1, I have this very sad, very pouty x to the exponent of -6. He's sad. He's not happy. All we need to do is move him where he would be more happy. Okay? And in order to do that, they either go from the top to the bottom or from the bottom to the top. This 6 right now is on the top, and it's not very happy up there. So all we have to do is move them down to the bottom. So we're just going to put x6 on the bottom. Again, very importantly, once you write it down, it should be a +6. Krista, are you with me, or are you playing some sort of app game in the back there during those? Just tapping for fun on the iPad? I got you. Okay. I don't know what you're calculating because we just moved a 6 to a 6, but I got you. Now, once this 6 gets down on the bottom, it's a +6. Now they are happy being on the bottom, and this answer's pretty much over, right? We got rid of the negative exponent. We moved it to the bottom. Now, you can't finish with nothing in the numerator. You need to have something up there. What number are we going to put as a little placeholder up top? Of course, just a 1. Just a little placeholder 1. Just move them up there. All right. Now, questions 1 and 2, super easy. You just move one thing and you're done. That's not really how this normally works. Okay? Question 3 is really where you kind of get into the big leagues. Okay? First of all, you want to look at the 4 things that you have. You want to figure out, are any of them unhappy? Okay? Sometimes people like to think about this like there's a party going on, right? And there's a top floor of the party and there's a bottom floor of the party. And maybe on the bottom floor, everybody's dancing and having fun. Maybe on the top floor, people are, relaxing and just kind of talking, and maybe they're on their phones a little bit. So what I notice is that this person right here, this person is unhappy. They want to go to the bottom. They want to go downstairs. They want to dance a little bit. But everybody else is feeling pretty good, okay? This Y4, they are definitely happy, just chilling upstairs on their phone, no stress. This X7 dancing, having a good time. This Y3 dancing, having a good time. So there's only one person that needs to move. We need to move this -2 to the bottom. And when we move this -2 to the bottom, it's going to be a +2 at the bottom. Everybody else is going to stay where they're at. The Y4 is happy. They're going to stay up top. The X7 on bottom is going to stay down there. And the Y3 is going to stay. Or Y3, if you will.
What about X2 and X7 add up to X9?
Exactly. So Brandon's already one step ahead of us. This is where we bring back in how our answers look. Our answers need to have no negative exponents, and that looks good. +4, +2, +7, +3. But we also are only allowed one of each letter. So now we have to take the double x's that we have and combine them into one x. We also have to take the double y that we have and combine it into one y. Your answer is allowed one x and one y. Krista, whatever it is you're doing, girl, I'm trying to work with you. We're in the middle of notes. Here we go, Brandon. Check this out. I agree with what Brandon said. We had 2 x's and 7 x's. They're both hanging out downstairs. 2 x's and 7 x's is going to make 9 x's. He was exactly right. These 2 x's are hanging out together. These are going to add together because they're right next to each other. If you draw a diagram of these x's, you're going to put 2 x's on the bottom, and then you're going to put 7 more x's on the bottom. And guess how many you got? You got 9 x's on the bottom, right?
How does that make 1 x and 1 y?
Because
How?
So I mean that there's only one x written down right here. Now there's an x power 9, which is kind of like there being 9 x's. But we have all of our x's into one pile is more what I'm talking about, Brandon. So see how it's like 2 piles at first? Now it's all one pile. That means we're good. So now let's look at the y's. Maybe I should add this, right? 1 pile of each letter. When it comes to the y's, we have 4 on top, 1, 2, 3, 4, and we have 3 on bottom, 1, 2, 3. Now these are not going to add together because these are on opposite sides, 1, 2, 3. They're going to cross off. So with these y's, top, bottom, these are going to subtract from each other. And we're going to have 4 minus 3, which is 1, and that 1y is left over on the top. And so we'll have 1y on the top, and that is the answer. 1y on top and x power 9 on the bottom. Now don't overcomplicate this. We moved something to the bottom. That's not even math. That's just moving something around. We added 2 plus 7. That's from first grade. And we subtracted 4 minus 3. That might be a little bit harder because subtraction is always a little bit harder. But again, that's not super crazy. Today's all about just being a bit organized, taking your time, and doing your thing. Okay, let's check out number 4. We're going to do this one quickly. It's not a hard question. I look at everybody at the party, and I notice that this person is unhappy because they have a negative exponent. They're going to want to move to the bottom. And I'm looking at this person who's on the bottom is also unhappy, and they want to move to the top. And that's okay. We can move 2 people around. Just move them around. Now, what else I notice is that we have this 4, and that 4 is just a regular number, okay? They're not ever going to move. So we're going to leave the 4 where it is. The 4 can stay where it's at. But this x power negative 4, he's going to move to the bottom where he's going to be happy, doing a little bit of dancing or whatever he's doing down there. And this x negative 9 is going to move up to the top and is going to become a positive 9 on the top because they're going to be happy on the top. And now we just need to combine into one pile of x's. You're either going to subtract them or you're going to add them. These are on one top, one bottom. They're on different teams. They're going to subtract. Anybody got the final answer? 4x power 5, and that's it. That's the whole thing. Again, not really supposed to be all that hard. Move it, subtract it. None of those steps are really hurting you. Now, I really like question number 5. It's going to show you something that you might be doing wrong, that you might not quite understand. Let's look, first of all, at this negative 3 here. Okay? Again, this is a moment that you're probably going to learn something one way or the other. Is this negative 3 going to stay on the top, or is this negative 3 going to move? What do we think? Stay or move? So we talked about how negative exponents are unhappy and negative exponents want to move. Is this negative 3 a negative exponent? No, this is just a negative 3. This is just a normal, plain negative 3, okay? He's going to stay right where he's at. Even though it's negative, it's not an exponent. It's just a number. You're not going to be moving that 3. However, this 7, that x power negative 7 is going to move. And this x power negative 9 is going to move. And this y power negative 7 is all going to move. These 3 are moving. But the y4 is going to chill. They're positive. And the 6, remember, if you have any plain numbers, they are never going to move. The plain numbers are always staying right where they are. So, if we set this up, the -3 is going to stay right where they are. The 6 is going to stay right where they are. The y power 4 is going to stay right where they are. But then we got some other stuff that's going to start moving around. Okay? The x -7 is going down. Now it's going to be a +7 because they're much happier on the bottom. The x -9 is going up. So they're going to be an x +9 on the top. They're much happier on the top. And the y -7 is going up. They're going to be a y +7. They're going to be much happier on the top. Again, we moved 3 things, but that's not really math. That's just being organized and moving your stuff around. Last time I'll say this, please look at what you've written down. You should never be writing negative exponents because we moved it and it's not negative anymore. If you have any negative exponents, not good. From here on out, we just need to do the actual dividing and figure it out. Okay? Our numbers in front are going to divide just like we did on the warm-up. You just do them straight up in Desmos. -3 divided by 6, which is -1/2. Next, I'm going to look for my x's. I see 9 and 7. How many x's should I have left? Are they on top or are they on bottom? Nice job. It should be x2 on top. And that's pretty easy. It's just 9 minus 7 makes 2. And lastly, we have the y's. 4 and 7. That's going to make 11. How come we added these together? Because they're on the same side. Because there's 4 of them and 7 of them right next to each other. They're on the same team. They're working together. You're right, it's 11, and of course those 11 are going to be on top. All right, we have one question left for the notes. We've learned everything. We've talked about everything. It's just time to practice, to move some of this stuff around. We don't have quite a ton of room for this question, so I'm going to make sure I write nice and neat. I'm going to give myself a nice big thing here. All right, how about this? I'll say something and you tell me if it's going to stay or if it's going to move. The +4 at the front, stay or move? Stay. The 8 A's, stay or move? What about the 3 B's? What about the C squared? Okay, like that's not very hard. Everything's staying. What about on the bottom? -28. Still, it's a stay. Nice job because the numbers never move. Only the letters move. 5 A's, stay. But finally now we have -6B and -2C. Of course, those are the moves. It really isn't that hard. The negative ones need to move. And so we can just go ahead and all of this stay stuff is going to stay, right? 4A8, B3, C2, or you could say B cubed and C squared, -28, A power 5. But these two things are moving. The B -6 is going to be B +6 on top, and the C -2 is going to be C +2 on the top. Now we did a good job. We got rid of all of the negative exponents. Now it's just time to combine our letters into one little pile. Okay? The number stuff, we can use Desmos for the number stuff. It's 4 divided by -28. That is -1/7. Anybody want to volunteer the A's? How many top or bottom? A3 on top. I heard a couple people say it. Nice job. Everybody that I heard got it right. Now what about the B's? How many top or bottom? The B's are going to be 3 of them and 6 of them. B9 on top. Perfect. And then the C's, 2 and 2, working together, making 4 on top. And that is our answer. Now, honestly, question number 6 is theoretically considered a hard question, but it's really not that hard. Move the letters and add them up, or maybe subtract them if they're on different sides. Okay? It's all about organization. It's all about taking your time. Remember, your answers have no negative exponents and one pile of each letter.
Should you just add this part and this part together or something?
So down here what happened, Brandon, is that the A's, 8 and 5, are different. It's a top and a bottom. That means we're going to use subtract. 8 and 5 makes 3 with subtraction. But the difference is that for the B's, which I have in pink, they're on the same side. So now we're going to use addition, because these are working together. 3 B's and 6 B's right next to each other, that's going to make 9. And then same with the C's. 2 and 2, they're both top. They're both on the same team. 2 plus 2 makes 4. I imagine this is going to be something that doesn't really help, but if you think about the A's again, Brandon, it's 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5. You see how they're on tops and bottoms, and they cross out like fractions do. But when it comes to the C's, it's 1, 2, 3, 4. They're not crossing out. They're all 4 on top. 4v0, it's just going to stay 4 and 0. All right, I think we get it. I'm going to go ahead and end the notes. Nice job. Make sure that you're not writing down any negative numbers. I think you guys get it. Good job doing the notes.